this. So I have some slides, and then maybe you have some room for discussion and questions, but also your views on it in the end. Because what I'll do is a little bit different than what I normally do. Normally I'm quite an optimistic person, but today I'll complain a little bit. And it might just be that, you know, maybe I just got up at 4 o'clock in the morning, I didn't have enough sleep, or maybe I'm finally getting old and I've reached this point where I start to complain about things. Both these things are possibilities. And maybe I'm somewhat right about some of these things, that there is some reason to complain about some things. So let's see how it goes. Now, of course, there's been a lot of progress in, let's say, the last decade in this topic of the robustness and transparency of the methods that we use, the statistics we do, the way that we design our studies. And I'm not going to deny this. I mean, it's pretty good. And I think psychology has moved from a field where, my field of psychology, right, which is my background, but it's moved from a field where people probably mentioned that, or said that we would be in some kind of trouble. Like I think a decade ago, we were definitely in some sort of trouble and our reputation wasn't very good for the quality of our research. I think we've moved in the last decade to be basically a leader in many ways in how you can improve the quality of the research that you do. And we've reached a point where we're, improving things for other fields as well. They draw some inspiration from what we do. Now I think my slides disappeared in some way. So I'll see if I can get them back. Somebody else took over the presentation. Let's see. But what I want to talk about today is a little bit of how we might be able to do better in some of the things that we're talking about now. And I think the point that I want to make is that some of the improvements we've been doing are nice, but they're not good enough. And I'm worried a little bit that because they might not be good enough, they might not be good at all. We might be making 2 steps forward, but we might have to make 2 steps back. That sounds a little bit negative, but okay. So maybe I just have a very high bar, and maybe I should not complain about how high my bar is because we're not going to reach it. But I think it's quite important to reach this bar. And I think we've moved a little bit in the direction, but we're not there. And I think if we don't meet a certain level, then the move in this direction is also not so useful. So that's basically what I wanted to talk about. And I'll give some examples of where I think this plays a role. So about 2 years ago, I guess 3 years ago, we looked at basic things that we think we should promote, like data sharing and code sharing, which has a goal, right? We do this not just to earn a badge or something. We do it because it makes something possible, namely that somebody else could open our data set, rerun our analysis, and maybe check certain things about these analysis and see whether they agree with us or not. Somebody also unmuted me. Okay. Anyway, it's fine. So in this project, what we did is we looked at some people who I think are early adopters in best research practices. So this is a sample of the first registered reports in psychology. So registered reports are this format where you submit your introduction and your research question to peer reviewers. They look everything through, and then if they think this is a good idea and you've studied something in the right way, they will give an in-principle acceptance. You continue with the data collection, and you can write it up without having to worry about, publication bias or whether you have to p-hack towards significant results. So I think the people who were the early adopters of these registered reports tried to do everything as well as possible. And then what we did is we basically just took a look how many of these people also share their data and their code. And then if we try to reproduce their analyses, how often do we manage to do this? And in this study, you see that among these highly motivated people to do the best possible thing they can do, because otherwise they wouldn't engage in all this registered report business. They wouldn't, of course, upload their data and materials or code. So here we have about 79 psychology studies. The data sets of these studies, there are like 62 papers with data sets. Of these, 37 have scripts available, the code to rerun the analysis, and 41 have data available, so they shared this voluntarily. Nobody had to share this. There are no requirements for this yet, at least. Together, the combination means there were 36 papers where the data and code were available. And then we tried to reproduce these analyses, and we managed in 21 out of these 36. That's pretty good, definitely nice result, but it's also far from perfect. So it shows that even among the people who are trying to do the best they can, our success rate is not very high. Many of these papers don't even share their data or their code to begin with. So, even in a subset of studies, I think it leaves quite something to be desired. Maybe we just need a little bit more time, who knows? But I think this is kind of symptomatic of what's going on. So we make some steps forward, but we're not really there. We don't do a very good job. I also see this in other kind of areas where, for example, people do change their behavior when it comes to statistical analysis, for example, or maybe practices such as pre-registration or any other kind of things that we've been improving, where you see that people do change their behavior, but they mainly do it in a sort of heuristic way. And what I think is often lacking is some sort of underlying understanding of the basic principles for why we do certain things. Now, this is understandable because having justifiable basic principles in anything is kind of a difficult thing to do. It requires a lot of thinking of why are we actually doing this, whereas imitation is easy, right? So you can quite easily imitate other people. You do something because they are doing it. And I would say that is more or less the modus operandi for psychologists. If you ask people, why do you do certain things? The answer is often, because this is how we do it. It's much more difficult for people to have a basic principle from which they reason for why they do certain things. And I think it's important to have these justified principles because otherwise we run into some troubles that I think we are running into now. Now, in these kind of discussions of how well we are doing as researchers, I think our strategy now in terms of promoting open science, which I think we all do, we care about. I mean, as an institution, the Reproducibility is trying to promote better research. In my own work, I try to do this. And very often we do this in a very positive attitude. So we, applaud anybody who adopts better practices. We say, hey, I know it's all difficult, but it really doesn't matter. You can just do whatever you feel like doing, and any small thing is the right thing. But we don't really say something like, well, if you're not going to do it well enough, don't even bother. That's much more negative, I think, statement. But sometimes that might be true, So I think, and by all means, you can disagree, you can point out that I'm wrong here, but I think that our current strategy predominantly is we applaud people to take small steps. We don't really say, this is the bar, you have to reach this point, but we just sort of motivate people just to get started, just to do something, whatever it is, and wherever they feel they have the best possibilities to make a small step. Now, I understand this in one sense because I think it's motivating in the short run. If you do a little thing of something that we consider a good practice, you get a lot of rewards and motivational speeches and well done and congratulations, and that's important. I fear it's going to be demotivating in the long run. Now, I'm making an empirical prediction here, so I might be wrong about this. But what I experience sometimes, and I've been doing this maybe for a bit more than a decade, so I have a little bit of experience trying to, improve practices and then maybe improve them more. But what you see is if you allow people to just do a little bit and then say, well done, then later you often have to go back to them and say, well, what I said was a pretty good thing a while ago, and I was so enthusiastic about it. Actually, it's not good enough. You actually have to do more. And we've seen this in a couple of examples, and I'll bring up some of these examples in the next slide. But then a typical response is, oh, really? It's really never enough, right? Now I did this thing and this other thing, and now you even want me to do more? Come on, where is it going to stop? Or something like this. And I think it's understandable, this question of where is this going to stop? Because we didn't say, look, this is the bar in advance. This is what we actually need. This is the goal that we're aiming for. We just said, move in the direction a little bit, and anything you do is great. But I think we should probably say, look, this is the goal we're trying to achieve. This is what we need to achieve that goal. Yeah, and if you're not going to get to this, this level, then it's not going to be of so much use. It's a much more negative attitude, and I want to apologize for it because very often I try to be a bit more optimistic, but I think it's time to discuss these kind of topics, and I'm curious to hear what you think. So I mentioned that if we don't justify things from some sort of basic principles, but we just do things because we do them heuristically or through imitation, then what you see is that this leads to confusion. That's what you would expect because we're not reasoning from basic principles, and then people try to explain behaviors or debate certain practices, and then, you get a bit of a mess. An example of this in recent years was whether people should pre-register and why they should pre-register. So if I ask you, why should people pre-register? And you take a moment to think about an answer to this question. Just think about it for a bit. Like, why should we do this? Is it because certain people tell you to do it, or is it actually a good thing? And then what is it good for? Then, in the literature, we actually see people say a lot of stuff about this. For example, a common argument to pre-register is it helps you to think better about your hypothesis. Or something like it makes your study more transparent, with which people often mean we can now see that you change your analysis based on looking at the data. And I guess then the assumption is typically that that's a bad thing, because it's something that you would also do if you try to p-hack, and we know p-hacking was bad. So pre-registration forces you to specify your analysis, and then we can see you deviate, and that's bad. It's not completely clear if that's true, and I don't think so, but okay. Or you might just say, look, it's a good research practice and we should do good research practices. But all of these lack sort of this basic justification. And a consequence of this is that we see debates in the literature where people say, pre-registration is not so useful, or maybe even harmful, or it's a waste of time, or whatever people want to say about this. But in general, the quality of these debates is actually kind of low. With which I mean that if we would get some philosophers to help us, where we clearly specify what our necessary and sufficient assumptions are, and where we specify what our goals are, we probably would prevent a lot of these discussions to begin with. But because we promoted pre-registration mainly from this practice kind of perspective, it's a thing you can do, it's actions you can take, and not from, look, this is a basic principle underlying our approach to science. This is the goal we're trying to achieve, and this is how pre-registration helps with this. I think it's a little bit, something that leads to these kind of confusions. So if we have a principle that we want to implement, like pre-registration or other things I'll talk about in a bit, then they should achieve some sort of goal, right? They're never a goal in themselves. We don't pre-register just to pre-register. We pre-register because there's some goal that we want to achieve. So it's important to think about what the goals are that we're trying to achieve. And also to be very clear about how we think the methods that we use will achieve those goals. So if you'd ask me why I think we need to pre-register, I thought about this for a while, and I think I can give you a pretty good answer, or at least an answer that I think is relatively coherent, that's easy, that can be defended based on basic principles. I wrote a paper about this, doesn't really matter, but I think for my case, if you want a basic justification of why we pre-register, then the reason that we do this is because there's a perspective on statistical inferences that's known as Neyman-Pearson hypothesis testing. And according to this Neyman-Pearson philosophy, what we're doing in science is we're making claims while we control our errors. So our error rates. That's the goal of Neyman-Pearson hypothesis testing, which I'm a fan of. Now, if you pre-register your statistical analysis plan, then it allows others to what we call transparently evaluate the severity of a test. And the severity of a test is basically how likely it is that you're fooling yourself, or how strictly you're doing a test that can actually prove you wrong. So the severity of a test is a concept from philosophers of science like Popper, but also Deborah Mayo, for example. And the severity of a test means that, you can think of it in this way. The least severe test you could do is coming up with the hypothesis after looking at the data. So this is a principle that we call harking, hypothesizing after results are known. If you're harking, you already know what the data is, so it has not been tested at all. right? Because you actually came up with the hypothesis after knowing the pattern in the data. So there has been no test at all. So that's the least severe test of a hypothesis. It's no test at all. In our hypothesis test, we have an alpha level, and you can see that the lower you would set an alpha level, the more severely you've tested your hypothesis in a statistical sense, because it's less likely that you're making a type 1 error, for example. So that's the severity of the test. Now, if we think about pre-registration, one of the problems we had with unpre-registered studies is that we don't really know if people have been trying a bunch of things. And all those flexible analysis we do, they also hurt the severity of our test. So we pre-register so that people can not control the severity of the test per se, because often we still deviate from some sort of plan. And by now we know this. We know that if people pre-register, not in all cases do they do exactly what they thought they would do beforehand. They often deviate. So that's just a matter of principle when we pre-register. It's also not bad. It's not problematic. It allows us to transparently evaluate the severity of a test, which means that if you now deviate from your original plan, we can transparently evaluate whether we think you did so in a sensible manner because your original plan was crappy, or whether we think that you're doing this to get a result that you want and you're reducing the severity of the test. So this is, I think, a principled approach to look at this. Without some sort of basic principle underlying a practice such as pre-registration, you get all sorts of discussions with people about why we do it. From this principled approach, I would say that, a pre-registered analysis, for example, is not necessarily better than a non-pre-registered analysis. If you pre-registered a dumb analysis and you perform it, that's not a good test of your hypothesis anyway. Sure, you've controlled your error rate, but you've not severely tested something. So sometimes you need to tweak your original analysis plan, but it becomes a better test. It's a more severe test. That can happen, because, again, the only point of pre-registration is so that we can transparently evaluate the severity of the test. Now, it also follows, I think, that if you're not testing any claim, you also don't need to pre-register. But what we see often is that people say, we developed a pre-registered protocol for these types of studies or for these types of studies. And I think it's great if people do this, but sometimes I wonder, why are we doing this? Like, is this even a type of study where we need pre-registration? And if we need it, what is it going to do? Now, people might have a very good argument for why we need it in those cases. That does not build on this kind of principle, which is fine, but often these kind of principles are, I think, mainly lacking. All right. So that's, let's say, a sort of philosophical basis for doing something. But I'm not done complaining yet. I want to continue complaining about this a bit. Because I also think that, okay, now you've pre-registered, right? You've pre-registered and you've gotten a badge. So clearly, this is good enough. Somebody gave you a badge for it, so this is what we're going to do. But that's not true, because again, if we look at this principle, then the goal of pre-registration in this case is to allow others to transparently evaluate the severity of a test, which means you need to have specified the test in sufficient detail so that they can evaluate how severely it was tested. Now let's take a look at what current best practices or good enough practices, I don't know, maybe not best, but at least good enough and common practices are in pre-registration, right? So this is clearly deemed as sufficient currently. Because this is a website which many people use to pre-register their studies, and it's called As Predicted. And again, it's a lovely website. It definitely gets people to pre-register their studies, which is great. And we didn't do it at all a decade ago, so I'm not complaining about the steps we've made. But I wonder if this is actually enough. And I think it might not be, because I now often have the case that if I review a paper which has been pre-registered, I'm like, what did I actually get extra? I mean, thank you for going through the motions. But this didn't really do what I needed to do, because what I need it to do is to be able to evaluate the severity of your test. But that doesn't allow me to do. And here it's maybe difficult to read because the gray area is sort of a default example test or text, sorry. So this is from the As Predicted website, and if you then specify your analysis, you can see what they write down as an example, just to inspire you, like this is something like what you would write here as an analysis. So here we have a verbal statement. It says linear regression predicting the simple average GPA in the semester after the intervention with a dummy variable indicating whether the participant was offered the summer program or not. That's your test, a linear regression. Okay, you know, and verbally, I guess I can sort of see what it is, more or less. But in our experience, if you then try to see what people really do in their paper and what their hypothesis is, it's so often unclear. Unclear in the sense that there's still a huge amount of variation left. Sometimes we're not even clear which statistical tests actually match the analysis that they wrote down that they were going to do, because maybe they'll do a couple of versions of linear regressions, or they do 2 variations, or whatever. I mean, there's just a lot of flexibility that often still happens. So together with Lisa de Bruyne, we wrote a paper about what do we think is necessary, what is the bar, so to say, of a good pre-registration. And one thing that I think many people do realize is that a good pre-registration, or a good pre-registration of an analysis plan, would basically specify the code that you're going to run on a data set. Maybe you already think, come on, that's way too difficult. Like, how are we going to do this? But we're going to take this idea just even a little bit further, because that's not even enough for us. And in our case, what we would like to have, ideally, or maybe minimally, I don't know where we are, but anyway, what I think should be needed here is a hypothesis test that is machine readable. Of course, it's useful if a machine could actually go into our data sets and extract information about our hypothesis test. You could come up with all sorts of meta-scientific or meta-analysis type of questions for which this is useful. But more importantly, we think that this should be the standard, because if a machine understands your hypothesis, then it's also clearly enough explained so that it is unambiguous. Because a computer cannot deal with ambiguity very well. So if we make sure that it's machine readable, then it's also specified up to a level of detail that the ambiguity is gone. So what would this look like? Make a hypothesis test like this? Well, this is an app that we made that nobody uses. It's fine. I mean, I thought this would be a little bit too advanced for people, but nobody uses this. But I just want to explain sort of what it looks like. And I'll show you some code later on that you can also use to do this. So in any case, there is an app. You would specify a hypothesis in the field and a hypothesis description. But I can explain it a little bit better if we take a look at code that underlies a Shiny app like this. So here you see that if we want you to pre-register a hypothesis, there are a couple of things you need to specify. The first thing is the test you'll perform. That was sort of like as predicted, but we want you to specify this in the code that would be run on a data set. So you see here that there's some sort of data set. There are variables that are used, and we perform a t-test. You know, so there's some sort of test that's being performed here, and we've specified this exactly as it would be run on the data. But this is also not enough. You also need to specify certain criteria for how you'll evaluate the results of this test. And that can depend on what kind of test you're doing, whether it's, for example, a null hypothesis test or an equivalence test, or it's a parameter estimate, or whatever kind of thing you're doing. We often have some criteria that we will compare it to. In a null hypothesis test, we would need an effect that is different from 0. And that's what you see here in the top. You see this comparator, that's 0. We're comparing our test result with 0. So we set up the criteria exactly, and then we also program the evaluation. That means if this result happens, then we will take it as corroboration of our hypothesis. And maybe even more importantly, if something else happens, we'll take it as falsification of our prediction. Now, this is again very strongly anchored into this Neyman Pearson hypothesis testing framework, and it's fine if that's not the thing that you're doing. Then you would, you know, maybe create a tool that looks a little bit different. But when people use this hypothesis testing approach, which is quite common in psychology, maybe even the default, I guess, this is the most formal way to pre-specify what you're going to do in your hypothesis test. I can understand that this is not very popular. You know, I think even if you're listening to me now, you said, Daniel, this is lovely, but you and Lisa are just huge nerds, which we are. It's true. And it might feel like this is super, super complex for something that doesn't need to be this complex, right? So why would we want to do this? At the same time, especially if you've tried to do some meta-scientific research where you're trying to extract information from the scientific literature, it's very difficult because people are very vague. So that's one reason we want to do this. There's a second reason that I think that's important. That's because Currently, we're often so vague about what we are actually predicting or not predicting that we often don't reach consensus about certain claims. And we've seen this in many replication studies that have been performed. People were so vague about what they were predicting that, any side could say, no, that's not what we meant. And very rare that we actually reach a point of consensus in science overall. Of course, that's also on the theoretical level that we are not very precise, but it's also because on the statistical level, sometimes we are not even clear about what would falsify a prediction at all. And if we can't falsify predictions, then, well, there we are. So this is an example of where I think we should go in terms of the level of specificity required to have a real pre-registration. And I know that this is, pretty far away from what we're currently doing, but this is, I think, what we would need, right? This is in line with what we need to evaluate the severity of a test. Let me give you another example, another topic that I've worked on where I think I also failed in making people adopt best practices, which is sample size justification. So we know now that, the rules that we use to determine our sample size, where we say something like, just use the same sample size as in the previous study, or use, when I was a PhD student, 15 participants for each between subject group is enough. Okay, now we realize that wasn't very good. So we need to come up with a sample size, explicitly say what it was for. So we don't just state our sample size, but we try to justify our sample size. And in one sense, you could say, Daniel, why are you complaining? Because you wrote this paper, sample size justification, appeared a year ago, and published it in Collabra. Just as a small side note, I just want to point this out, that this paper is cited a lot. So in a sense, you would say, Daniel, this must have been quite successful. It's cited about once a day. You definitely can't complain about that. I also want to point out for all more senior researchers that, whenever you publish a paper by yourself, there's no one else involved, there's nothing holding you back from making a good choice of where to submit this, right? I could predict this would be a pretty popular paper, and I intentionally send it to a journal that I think I wanted to support because it has a very high standard in terms of open science practices. So this is just a side note, that when you have no other interests and you're working by yourself as a senior scientist, there's nothing holding you back from ignoring certain journals that we consider problematic and sending it to a good place. So, okay, I did this. The paper is cited a lot. Yes, this is sort of humble bragging, I know, but I actually have a point to make here. And that is that it's cited a lot, but actually it's never used in the way that I would hope people would use it. This paper also comes with its own shiny app, because it's a very long paper, there's a lot of stuff in there, and doing a good sample size justification, in my view, requires going through a number of steps. And only if you justify each of these steps are you actually justifying your sample size. So this app tries to allow people to do this. You can literally just click through each step. There are menus that you can select, and then you fill in certain things that forces you to think about, okay, what am I doing here and why am I doing this? And all components that I think are necessary for a good sample size justification would be met if you diligently go through the whole flow line in this shiny app. So in the bottom, I said, how often has this been used? I don't know, but if it's more than 10 times, I would be impressed. I think it's probably even less. Instead, what people do, is, I don't know, is it a sample size justification? It's probably better than whatever they were doing 5 years ago. But it's not really up to the level where I hoped it would be, because a real justification is much more work, much more difficult to do. And I think people just, do maybe the minimum amount of effort. Again, it's probably better. What they're doing is probably better than what they're doing before. But we're still, I think, far away from what I would hope would be a real justification for something in a paper. All right, so these are some examples about pre-registration and about sample size justification, which are just topics that I've worked on. But I think this is not limited to, the statistics that we report, or how we report our analysis plan, or how we design our studies and justify key aspects of our studies. But I want to give one last example, which is about how we share our data, where you have the same principle. So, let's, for example, take a look at the Open Science Framework which again is an amazing site. It's great the way that it works. And definitely when it started in 2013, there wasn't even a way to share any of your data. So I'm not complaining at all about how it works. But it definitely has this philosophy of let's just get people started. And that's good enough for now. But I wanted to compare it with an alternative solution. So, all right, so on the Open Science framework, if we take a look at what's necessary there to share your data or other files, you can share whatever you want, but specifically here, your data, this is basically what you have to do. You have to click this upload button, and then you upload it. And then it's on the OSF. That's it. That's all you need to do, which is, of course, super simple. There's also some issues there. For example, how can I really find your data? Or how do I know what's in the data or something, you know? Now, I have to say that recently they added a feature to add metadata. So you can now add this. But people are used to not having to do this because, you know, they could just upload it. So I'm very curious how many people are going to actually make this data findable and accessible, you know, all these FAIR principles that people have been talking about. Now, they're trying towards this, but just want to compare it with an alternative philosophy, so to say, of how to embrace best practices. So this is by Zedbit, which is a German institution also promoting open science. It offers many of the same services that the Open Science Framework does, but it does it a little bit of a different way. So one feature they have is Psyc Archives, which is basically a repository, online repository where you can share all your data. But here, if you want to upload something, yeah, the uploading is just one thing, and then you encounter a couple of screens like this. So you're forced to specify first some basic metadata about your file, like who uploaded this, what is it, describe it a bit. Then you can even they made it optional, but they really sort of want you to do a lot of this stuff as well. You know, like where is it from, add keywords or, you know, tags about it or all these kind of things. And then there's even one more link, and that is, what is this related to? So if this is a data set that is related to some sort of paper, you have to specify the DOI of that paper, if you can do it. If this is related to some sort of code, so this data is produced by a code that has been run, you can specify all those kind of relationships between files. And this is kind of interesting because now all of a sudden you realize, hey, wait, so if I have the paper, I can see, okay, what is directly related to this and how? There's metadata involved. So you have an extremely well organized system of data files if you run this for a decade, compared to if you run the OSF for a decade, which we have done. So we can take a look at, okay, if you would go into the OSF, how much of this data is actually useful? I don't know. You know, it's better that it's there than if it's not. So, I mean, I'm not complaining at all, but I think this is kind of the standard that you would want a field to move to. At the same time, I also think it's very difficult to get people to move even further than when they say, look, I already shared all my data. Surely this is good enough. Can we please call it a day? You just keep making life more difficult for me. But the point was never really just to share your data, right? The goal was to share it in a way so that others can find it and access it and reuse it, right? Which this approach probably manages a little bit better. So for a lot of these things, the question, of course, that comes to mind is, so when is it good enough, right? And how much effort are we going to put into doing something good enough? And I like this quote by Donald Hebb, who says, if it isn't worth doing, it isn't worth doing well. And that sometimes worries me, you know, that we actually don't care about doing it well because maybe it's not worth doing. Now, that's maybe more a discussion for over a couple of beers of when this is the case or not the case. I definitely think it's fair, for example, to discuss, should we really upload every data set of every student project in this very rigorous way? Maybe, maybe not. You could also say, let's get started by doing maybe data sharing on all these things for the most important projects that we do, published papers in the scientific literature, but then make sure that those are done at this high standard. Now, how can we get people to this bar, right? How can we make sure that they pass a certain bar? One way is just to hope that they do it and wait until they do it. We can offer some training, of course, that's useful and important. And then we just sit there and hope that the field drifts towards this bar. I don't think that's probably the best way. maybe it's also a sign of getting older, but I feel a little bit more like, yeah, maybe we need to push people a little bit more. And I mean, I think there are also many examples where if there's some sort of checklist people have to meet, or, you know, all these boring things I know, or if a scientific funder tells you that you have to share all your data or otherwise you can't get funded, then people start to do these kind of things. So I think there's some sort of external pressure that's necessary, and I think this is just how people work. Maybe that's not popular among psychologists, but I think an economist would, for example, say, yes, of course, that's how people work. So one thing that we could think of is we just start to require certain better practices. Let's say my sample justification app that people don't want to use. All right, but now we ask somebody not just to, you know, send it, do the sample size justification themselves and then send it to a journal and hope that they think it's okay. But let's say we have some sort of committee, just like we have an ethical review board. We can have a methodological review board, and they also check certain aspects of the study before it is allowed to proceed. Now, maybe this is just my frustration that people don't do these justifications very well, and I just want to force them to do this. This is just my, you know, power grab to get people to do what I want. But I think there's a bigger point here as well. That is, if we have some sort of system that requires people to do it, we take this responsibility, then an institution would also require that you make it possible for people to do the best possible job. And I think this is a topic that we don't really discuss. One of the reasons I think why we say, look, just get started, it doesn't matter how far you get, is because if we would say, look, this is the bar and you need to get there, that would require a lot of time. We don't have that much time in the system, right? Now, often the limiting factor is just how good a job can you do on these things given the time that you have. But you can also think, well, maybe then we shouldn't do it ourselves. Maybe we should just hire people to help us with this. That doesn't seem too crazy. So if we have a methodological review board, we would also hire people to help you to meet this bar so that the quality is good enough. It would pass this methodological review board. We don't ask you to just do it by yourself. This is some expertise and specialism. Maybe you don't have it. Maybe it's not even efficient if you learn it and everybody learns it, but we have somebody there to help you with. So we would hire specialists to do this. Same, for example, with computational reproducibility. We could hire people to do that for you, make sure that your data can be reproduced. There are already some cases where we force people to have this reproducibility. So this is the journal Meta Psychology, which in terms of rankings of how open science practices oriented a journal is, I think it scores the best of all journals. It implements a lot of the things that probably you've talked about during reproducibilities. And one thing they also do is they have a statistical reproducibility check before the paper goes in press. After it's been accepted, so it's not a requirement before it's accepted. You could just submit your paper for review. But then if the review process is done and people have said, OK, we can publish this, then the editor and an assistant will help you through computational reproducibility check to make sure that the files that you upload are also reproducible. And this is not the only journal that does this. There are a few, not a lot, but there are some. For example, in economics, there are a couple of journals that require this. And then all of a sudden, you know, yeah, you're forcing people to do this, of course, maybe helping them a little bit, but you make sure that there's this bar that needs to be raised. So it's not just your data somewhere, your code is somewhere, like with the registered reports we saw in the beginning, where often people can't reproduce it, but you say, no, this is a bar you need to meet, and we're going to check if you meet this bar. All right, so that's my slightly depressing kind of thing. And then I think, why don't we talk about this stuff? Well, I think nobody's going to make friends saying that what we are currently doing is not good enough. It's just a very depressing story. So that's why I want to say what we are currently doing is, I think, just not good enough, regrettably. That's not a criticism of everybody trying. This is just to be expected. You know, this is how it works. We are not currently at the pinnacle, the best point of science ever, you know. There are people 200 years from now who are going to look back to us and think, what the hell were they doing? You know, how could you even do science in that way? So there is, of course, progress. Progress is slow, but nevertheless, we need to keep thinking about how we raise the bar and maybe have some uncomfortable conversations about what that actually entails. All right, that's the thing I wanted to say. There's some room for questions. I want to advertise two things before we get to the questions. First is we just started a podcast about science, what it is and what it could be. That's the motto. If you're interested in these kind of things, check it out. And the other thing that was mentioned, if you thought I was going to give you all sorts of practical advice how to design better studies, I'm very sorry that I didn't do this. But as was said in the beginning, I do have 2 free online courses where you can find this kind of information if you want to. All right, thanks.
Great, thank you, Daniel, for your presentation. So we're going to start off by taking some questions from the room. Wait 1 minute.
Okay.
Okay, so I don't see any question in the room, so maybe we'll go off to the questions online. So I see Nicholas has his hand up. So Nicholas, you can go ahead.
Hi there. Thanks for a really enjoyable talk. I've downloaded lots of PDFs while you were talking, so lots of reading to do. I wasn't familiar with the app and your paper actually. My question is more a thought I had related to like again your talk is very philosophical and you've kind of pitched it like that, and related to what we can do working within science. Because science is, working within positivism and the sense that maybe we can do things which are objective or separate from the world. And as scientists try and do that. But then, I've got colleagues who are qualitative researchers. I've got colleagues who are like engineers who just trying to do something that works, and kind of, develop models and simulations. And, maybe the kind of path you're going down in your talk, is an extreme version of positivism. Okay, just to put that out there, and maybe that has limitations which people struggle with, therefore, in terms of we're missing out on context and that's causing reproducibility problems, etc., like that. Does that make sense? So it's more like a philosophical question for you about, we can do all this other stuff to make our work reproducible and more objective, but there are just inherent limitations and tensions within that. Yeah, I think so. Philosophically, I think the perspective is methodological falsificationism. So it's not positivism, actually, but let's say slightly more advanced versions of where this led to in history. Work by Lakens, for example, or Deborah Mayo. They're important people in this field. And but it's true. So this is about claim making in science, according to this specific thing. Now, I don't think that's the only thing we do. Let's get that clear. We actually have a paper in 2021, which is called Why Hypothesis Testers Should Test Less Hypotheses, where we say, look, this is basically one often final thing that we want to do after a lot of other stuff, naturalistic observation, explorative kind of research processes that go before all this kind of testing, right? Now, so this is in a very specific context, but in this specific context, these are kind of the necessary tools to achieve certain goals. And it's fine to think about what would be the goals in other kind of research lines where you have other kinds of questions, right? But I work at a school of engineering, for example, and those people also want their tests to be reproducible. They have the same sort of goal of making things reproducible. So I see that there are some limitations of this specific thing. Those just happen to be the ways that I, do tests, for example. I think the general principles of where a bar should be to have reproducible, transparent science, even if your methods differ, there's always some way to specify it. And I think the same kind of mechanisms play a role, where we don't really force people to meet this bar very often. Like data sharing is kind of the same issue in chemistry, for example, at my university than in other fields, right? They also don't like to do these kind of things. Yeah. Yeah. Thank you.
Okay. If we have more questions, please feel comfortable putting your hands up or just type in your questions in the chat. Shafak will be happy to read it out for you.
Okay, I think there is one from Josefina. She's thanking me for the talk. And another philosophical question. So she's been reading Feyerabend's Against Methods recently and was wondering If you have any thoughts on how his opinion on method or lack thereof of science would mesh with open science practices, was he completely wrong about how science should work?
Yeah.
Thank you, Josephina.
Yeah. I'm not a big fan of the book. I understand that many people read it. It is a classic. So it's interesting because he wrote this, and the goal was that Lakatosh, Imre Lakatosh, would write the opposite book, For Method. And they were friends. But Lakatosh died before he could write the second book. So we only have the against methods, but you're not reading the For Methods part, which was originally planned to be the accompaniment of this. And I think Feyerabend himself often says, look, I'm taking things a little bit extreme here, because that was the whole point, you know, that he was going to be arguing against my extreme viewpoint. So you should read it in that sense. And I think in practice, Feyerabend says, you know, there are a lot of methods that you could use. There's not a single method. And I'm actually fine with this. What I typically want is justifications. If you do something, and it doesn't matter what your goal is or what you do, but you should have some sort of justification for why you are doing something. And even if that justification is, let's say, the most extreme version is, my approach to science is messing around. I'm messing around, and I'm going to go for the sort of weird discovery of something that I found, which I think never really happens in practice, but okay. People often say this invention of penicillin is an example of an unintended discovery. Well, it's not like those files of stuff that measure it were just not there. They were there, right? Somebody was studying something and looking for something anyway. So it's never really that extreme. But the main thing is have some sort of justification for why you do what you want to do. And then do whatever you want as long as it's coherent.
Thank you, Daniel. I think we have Sarah's hand up.
Hi, can you hear me? Okay.
Yeah,
great. Yeah, thanks for this talk. It's great. I have not read your paper about sample size justification. I will do that. I was just having a look at the Shiny app, and I think it looks like a great tool. So I have a kind of a question about that. Sometimes I do like this research where don't have a hypothesis. I'm just trying to gather a bunch of data for descriptive purposes. And I have a lot of trouble trying to figure out what is a good sample size for a study like that. So, and I noticed that, for example, in the tool, you have things like the smallest effect size of interest, which is really a critical concept for hypothesis testing. But I don't know, maybe it's already in the paper, maybe it's in the tool. Just looked very briefly, but do you have any kind of guidance or advice about how to do this other kind of study?
Well, I mean, it's good that you say it looks useful. That's nice. It's not an advertisement to read this paper, for example. I mean, I guess people find it useful, but so there are two possibilities. First, the possibility is my tool is not developed enough so that your goal fits in it. That's a possibility, right? And again, we want sort of principled justifications, and I didn't come up with this case. The other possibility is that you're now forced to reach a certain higher level of justification for something, right? Because before you could probably just say like, okay, I'm just describing stuff, and this is my sample size, the end. And now we're forcing people to think, okay, so what's the justification for this? And then you're like, yeah, what is my justification? You know? So that's a good step, a necessary step. In description, one of the goals sometimes is accuracy in terms of estimates, right? So you describe something, but you do it quantitatively, and you want that to be accurate enough to reach something. And that goal is in there. So there's an estimation accuracy kind of justification, for example. Beyond that, there sometimes, which another goal is just feasibility limitations. I'm going to get as much data as I can. And one of the reasons I think the paper is so popular, because it explicitly says that is actually sometimes just in practice our justification. Just like, this is how much money I have. This is how many people I can collect. That's it. Then, of course, you should think, is it informative? That's the last difficult step. But right, so there are these pathways through it. And maybe sometimes there's another justification that we can come up with that we didn't, right? And that's also part of improving these things. But I guess it illustrates the importance of raising the bar, of asking, you know, why? Why are we doing this? What is the reason for it? And then it should sometimes be that you're like, I really don't know, actually. I have to take a moment and think about it and maybe talk to some people about it. That's very normal behavior. But if we don't force people for this step, they're going to write something up. I mean, you can take two routes now. you can just say, look, you said this feasibility thing. Okay, I'm going to cite your paper. I'm actually not going to go through the whole app. I'm just going to cite your paper and say, yeah, feasibility limitations are real, Lakens 2022, the end. But that wouldn't be like the last step. Like, why is this now an informative study? That's a very tricky thing. So forcing you through the app would make life more difficult for you, right? And that's, I guess, really the thing why it doesn't happen so often, because it is just more difficult. And you would need some help maybe, you know, and which you can always do, by the way. I mean, people email me all the time with these kind of questions, and they're also for me interesting to see. So, but anyway, yeah, it's difficult to do. Okay.
Thank you.
Okay, we have another question from Stefan. He's wondering if you know or what open science measures such as sharing data or code or pre-registration can really help to improve science, or put it more concisely, do we really know which efforts are worthwhile?
Well, I think it's a great question. And if that question, you know, if this talk raises that question, I think that's exactly the point of the talk. So I can try to give you some of my answers. It's actually not that interesting. It's more interesting to hear what, as a field, do we think about these things, right? So what is worthwhile to do and how much effort is worthwhile? There are some open science improvements that I do think are useful, like registered reports, for example. And we did take a look at registered report. What happens if we take away the requirement to find significant values, or if we take away the evaluation based on the data, basically, and we do the acceptance before you've collected the data. So we have a paper on this with Anne Scheel, and there 2021, and there we see the percentage of null results is massively higher compared to the standard literature. So in the standard literature, 96% of the stuff we do ends up being significant. What a wonder. I mean, that's amazing. Registered reports have something like 44%. So we see that this is a way to get null results, interesting null results, because the reviewers thought the study was interesting null results in the scientific literature. So there, I think we have a really clear goal and a mechanism, and everything is pretty okay, I would say. For questions such as data and code sharing, for pre-registration, I also think I know the answer, right? So there we want people to allow a transparent evaluation of the severity of the test, which basically means, have you been messing around with your data so much that you're fooling yourself, and I think you're fooling yourself, or, you know, did you make some changes, but I can see why you made those changes, and I agree it's a better test. So there it's transparency about how severely a test has been performed. And remember that we started this stuff because Daryl Bem in 2010 published 9 studies into precognition and found significant results in each study. And we were sort of like, how? Whereas if we could have seen what happened, we would be like, yeah, that was not a severe test at all. None of those were severe tests, right? So that would have helped us then. For data sharing and code sharing, I think we need to have this discussion much more. I have no idea how often people reuse somebody else's data set, and which data sets are reused, and how much effort we should put into it. I think that's really a question, because it takes some time. It's difficult to do. So there, I can't answer the question, and I hope somebody picks it up.
Okay, thanks, Daniel. We have 2 hands from McNeil and McNeil.
Hello, thank you,
Hey.
Daniel. I'm looking at your Shiny app paper with the sample size justification, and I'm both happy to say it looks very good, informative, and it's also a long paper. But I wanted to ask, does the app calculate a sample size for you? Like,
No.
what's the goal? What's the goal?
Yeah.
When you enter all this information, there's a lot to enter. What does it give you in the final report that you get?
Yeah, exactly. What are you getting out of this? So it doesn't compute anything. I mean, in the paper, there are a lot of links to stuff where you can do power analysis. I mean, I've written a paper, for example, we have a package in R called Superpower, which is a very funny name, but also a really good tool for power analysis in ANOVA design. So if that's your specific test, you can go to those kind of papers. We point you to it. It's also true that this is a very long paper. You're completely right. One of the reasons I submitted it to Collabora is that they don't have a word limit. The reviewer said, can't you make it shorter? I said, no. No. Anyway, but what you get out of this process, it's a weird thing, right? You get a very good justification for what you're doing. And I think you have to value that. You like, why am I going through all of this? Because now you know why you are doing a certain study, why this is an informative study. So it should be extremely convincing in a registered report to go through this app, for example, and say, hey, I've designed the study. This is why I think we're going to get informative data, because I clearly specified all the things I need to specify. And then the reviewers could go through it and be like, very convincing, clear. That's what you get out of it, basically. And then in the end, you still have to do a power analysis or accuracy-based sample size justification or something like that. Yeah.
And can you justify? You still have to do the power analysis then, but okay, I get.
For example, if that's your endpoint, it could also be that your sample size is based on something else, not a power analysis. It's only one of the many options that you would end up in, but yeah.
Okay, thank you.
Thank you. I think next is Nicholas.
Yeah, another quick question. Sorry, this conversation is great and making me think. What about when your sample size is 1? So there's a trend now towards N of 1 studies, where you like in health psychology. Does your app, or I need to read it, thoughts on like how many measurements you should use per, to understand the effects of an intervention? Does your paper or your app allow us to understand that better? Because this always comes up in conversation with colleagues. How long should we sort of measure for, or things like that?
Yeah. So this is why the paper is so long, because there are always questions like this. And yes, the paper discusses N is 1 studies, and it gives you some references towards them. Yes, the combination, it's a sample size justification, not the number of participants justification, but the combination of number of trials and participants and all that is explained in the paper. Yeah.
Thank you. Lisa, next, please.
Hey, Lisa.
Hi.
Did you read Popper yet?
Not yet, but I will. Thank you for the recommendations. And also thank you for the presentation, which I found really interesting. And I totally agree with the issues that you raised, especially on the point that people should talk more about the fact that things should be actually reusable or done well enough, not just be available somewhere. As an additional approach, I think it's important to not just argue for the feasibility of open science techniques on a theoretical basis, but also monitor their feasibility and also like do usability tests. For example, when you talked about pre-registration and about deviations, I think now we get more and more evidence that deviations are not properly disclosed most of the time, and this could even lead to false sense of confidence when readers think that things have been done as pre-registered when they haven't. And so I think that this monitoring could be, in addition to defining expectations, be a good option for getting into the right direction a little bit more. What is your opinion on that?
Yeah, I think, well, I mean, you can have 2 approaches. One is sort of, and that's the approach we're in, which is sort of, it reminds me of what my industrial design colleagues do. And we make something, and then we have an iterative cycle of improvement. And that is what we are doing now. And you could probably have an approach where, I don't know, the mathematics department in my university would probably say, well, how about we sit down, we think very carefully about what the optimal system is, what the necessary conditions are, what are we trying to do, and then we build a system that has as much. And both of these approaches have their limitations. The one is we're just sort of trying around, and sometimes we're going in the wrong direction for a bit. We have to fix it all the time. And the other is, maybe it doesn't work in practice, But I definitely think that, we're doing this iterative cycle. And I don't know how often we can iterate before people are like, come on, another thing, come on. And, so some balance there would have been nice.
Yeah, that makes total sense. I wonder if it's always if there's this one framework that's like a perfect framework on a theoretical basis, because I think it might be difficult to, from our point of view, from where we are now standing, to define the perfect way. And then if we move toward that and we find out on the way that that is not actually the ideal way of doing it, that might also be difficult to deviate from that then.
I agree, but sometimes, you know, if we would have thought from the beginning, like the goal of pre-registration, we always said stuff like it's, you know, it's a plan, not a prison. And I mean, I said this as well, right? But wait a second, what does it actually mean? It means this other thing, and therefore deviations are then maybe expected or fine. So then from the start, you know, we didn't have forms from the start that said, now describe possible deviate. I mean, you know, it's just like that. I think we can do a bit more. Yeah, maybe.
Thank you.
Thank you. And I think we had Tao's hand raised previously. Tao, would you like to go ahead with a question?
Yes, well, I think that the question of the issue has been more or less solved or addressed in the previous term with Lisa. Yeah, it is more or less that, like a practical example that say that you have like a pre-registration of a hypothesis with a given technique, for example, say Pearson correlation. But then when you are writing the manuscript, you get combined in that, well, Kendall is better because the normalization, because the stuff, and then you get combined to that. So yeah, my question is, would it be better to say I deviate? This is a deviation from pre-registration because I get to that conviction, or yeah, because on the other hand, people could say that it is like an excuse that you thought. So I think that is a balance that you were talking about before. So
yeah,
I think clear white lines in that.
Yeah.
That point.
No, so I mean, they're saying if it's better or not, I don't think we know. And I think there are a lot of these things where we need to be transparent about the step and then start to talk about what does this mean, right? And those are difficult questions, like when is this justified, when not, which criteria would we use to evaluate those kind of questions? I wouldn't know at this moment, you know? So I think we just need to start doing it and then figure out what those things are.
Thank you.
Right, I think I'm afraid our time is up. So I would like to thank Daniel for a very interesting and insightful and thought-provoking session. And I would like to thank everyone for listening and asking such interesting questions. Thanks so much. Just to remind that we will be sharing a recording of the session on YouTube and also posting it on Twitter. So do follow us for more news. Meanwhile, yeah, enjoy the rest of the day and thank you very much.
Okay, thanks. Bye.
Thank you.
Thank you. Bye.